Hello, my name's Manjot Singh. I'm lead enterprise architect at MariaDB, and I'm here to talk to you about InnoDB durability, and specifically the variable InnoDB flushlog at TRX commit. This variable controls the durability in ACID compliance. ACID compliance, as you may know, stands for atomicity, consistency, isolation, and durability. So specifically this durability versus performance. And there is a bit of a trade-off when you look at this variable. The possible values for this variable are 0, 1, and 2. So let's take a look at what these mean for us. So we'll write them down on the side here, and we'll take a look at how they affect things. The specific path of a query goes through the InnoDB buffer pool. We'll put BP here. Then the log buffer from the InnoDB redo logs, the OS buffer, and then finally to the log file. So let's start with 0. When InnoDB flushlog at transaction commit, sometimes called iflact for the initials, is set to 0, you do a write, and it goes through memory, through the buffer pool, into the log buffer. After that, that write is then flushed from the log buffer all the way to the log file on disk every 1 second, or when the OS flushes. If you set it to 1, which is maximum durability, your write goes to the log buffer. So again, this is your write and commit. But the commit of the file ensures that it is written all the way on disk with every 1 transaction. If we set it to 2, this is sort of a trade-off. So 1 will have quite a bit of a performance hit as compared to 0. 0 means it just writes, it's in memory, etc. What 2 will do is write to the log buffer, but that file will actually be committed all the way to the OS buffer. And then, at some point, the OS will flush to disk, approximately every 1 second. So what are the advantages and disadvantages here? Well, when it's set to 0, if the database crashes, the log buffer within memory will get lost, and you have a chance of losing that transaction. So that can be bad. So you've lost a bit of durability, but you've gained quite a bit of performance. If you set it to 1, every write is for sure written to the redo log on disk. You do not lose that write regardless of the crash. What does 2 give you? 2 is a good compromise. You get almost about 75% performance boost. So you only lose about 25% performance as compared to 1. And if the database crashes, you can see it's still written to disk, well, at least the disk cache, and then written to disk later on. But if the database server crashes, that database's OS disk buffer has a chance of losing data. Now, this is negated if you have battery-backed backup. You might have a SAN, and in that case, your disk is safe. So 2 is a great compromise if you have that battery-backed RAID or SAN, or something of that nature, and the database crashes, or even the entire server crashes. So that's basically InnoDB flushlog at TRX commit and how it works. Thank you.